Hi all, this is Guided Practice 9 on section 2.7, quadratic inequalities. Let's start here with number 1. So we want to be able to solve quadratic inequalities. And so there's a 3-step process to this one. The first thing we're going to do is we're going to start by getting a 0 on one side. So we're going to maneuver things back and forth so that we have a 0 on the right. Once we've done that, this one's already like that. Once we've done that, we're going to go, and step 1 is to solve the equation version. So x squared plus 4x plus 3 equals 0. Okay, so when we solve a quadratic equation, we're going to try to factor, and this one does factor nicely. Two numbers that multiply to 3 but add to 4 would be x plus 1 and x plus 3. Then we set each of those two pieces equal to 0. So x plus 1 equals 0 means that I get x equals -1. And x plus 3 equals 0. When I subtract the 3 to the other side, means I get a -3. So now I have two numbers. So step 2 is going to be to create some intervals. So what we're going to do is we're going to draw out a number line. And I'm going to put my two values on there. So I have -3 and -1. -3 is smaller, so it goes on the left. -1 goes on the right. And then what we're going to do is write out the corresponding intervals. So we have from -infinity to -3, -3, stop at -1, and then -1 off to infinity. And now what I'm going to do is I'm going to choose a test point. So any number within that interval. So I'm going to choose -4 over here, -2 between them, and 0 over here on the right. And what I'm going to do is I'm going to test all three of those points in the original inequality. So I'm going all the way back to the original one, and we're going to start with -4. So if x equals -4, and I'm plugging it in here, then I want -4 squared, which is 16, plus 4 times -4 plus 3. So give me 16 minus 16 plus 3, and I get just 3. And the question is that greater than or equal to 0, right? Because that's what's on the left here. And the answer to that is yes, 3 is greater than or equal to 0. So that means that this is a good interval. This is yes. Okay. Then we're going to check the -2. So if x is equal to -2, we're plugging into the original. So x squared would be -2 squared plus 4 times -2 plus 3 is what's on our left. So this is 4 minus 8 plus 3. 4 minus 8 is -4, plus 3 is -1. And the question is that greater than or equal to 0? And the answer here is no, it's not. So that means we're not going to use the interval where -2 is. So we're going to cross that one out. And then I'm going to check my last one, which is x equals 0. I like using 0 because anything with an x becomes a 0. So our x squared becomes a 0, our 4x becomes a 0, and I just have the plus 3. So I just get 3, and is that greater than or equal to 0? And the answer here is yes. Okay. And so that means we do want this one right here. Okay, so step 2 is to create and test your intervals. And then step 3, we're going to go ahead and give our answer. Okay, so I'm going to draw it using a number line first. So we've got our -3 and our -1. And now I'm going to go all the way back to my inequality. And notice here that my inequality is greater than or equal to. And the or equal to means that I'm going to include my endpoints. So I want closed circles at my endpoints. Okay. Then I don't want if I look up above here at my intervals that I tested, I don't want the middle. I only want the end. So I want this one. And I want this one. And if I turn that into intervals, that'll be from -infinity to -3, include -3, include -1, and go off to infinity. Now, WebAssign, when you enter answers on WebAssign, will want you to put a union symbol in the middle. And that just means we're taking both of those things and including everything from both of those intervals. If you use the upside down version, that means intersection, and that means what they have in common. So we don't want that here. We want what they have. We want all of those things. Okay. All right. And that is our answer for number 1. Now keep in mind that these are inequalities, so we're looking for a range of values that are going to work and not just one answer. So this is my range of answers that will work. So any number within those intervals should work when you plug it in. Okay. Let's take a look at number 2. This one has a cube, but we're going to start out exactly the same way. We've got a 0 on one side, so we can go ahead and solve this. And we're going to start by solving the equation. So we're going to start by solving x cubed plus 2x squared minus 4x minus 8 equals 0. This one has 4 terms and it's cubic, so we're going to try to factor by grouping. So if I take these first two, they have a common x squared. And when I take it out, I get x plus 2. And the second two have a common -4. When I take that out, that's x plus 2. Then I can bring that common x plus 2 to the front. And I'm left with x squared minus 4. Now from here, I'm going to go ahead and factor again. Right? We worked on this at the beginning. In that first chapter, we want to factor again. So x squared minus 4 is a difference of 2 squares, so I can make it x plus 2 and x minus 2. At this point, we set each of these equal to 0. This gives me x equals -2, x equals -2, and x equals 2, right? If you're not able to jump there, take your time, write it out, x minus 2 equals 0, and add your 2 to the other side. Notice that these two are repeats of one another, so that's going to make things a little bit funky in our answer, but that'll be okay. We'll deal with it as it comes. So that's our part 1. Part 2 is when we're going to create our intervals. So we're going to set up our number line. And we're going to put on -2 and 2. And then we're going to choose a number. Here are my intervals. Sorry, -infinity to -2, -2 to 2, and 2 to infinity. And I want to choose a number in all 3 zones. So a -3 over here. I'm going to choose 0 here and choose 3 over here. And then we're going to go back to the original and plug them all in. Okay, so I'm going to start with x equals -3. And that's going to give me -3 cubed plus 2 times -3 squared minus 4 times -3 minus 8. -3 cubed is going to be -27. -3 squared is 9. So that's 2 times 9 minus plus 12 minus 8. And so that's -27 plus 18 plus 12 minus 8. All right, what do we got? So 18 and 12 is 30, minus 8 is 22, plus -27 gives us -5. Is that greater than or equal to 0? No, it's not. So that interval is one we're going to cross off. That's a no. And then we're going to test 0. Again, I like 0 because anything within x is 0, so this is 0 plus 0 minus 0 minus 8. So I get -8. Is that greater than or equal to 0? And the answer here is no as well. So that middle interval, also a no-go. And then lastly, we're going to choose +3. So we're going to take 3 and cube it, plus 2 times 3 squared, minus 4 times 3, minus 8. That's 27, plus 3 squared is 9 times 2 is 18, minus 12 minus 8. Okay. -12 and -8 is -20, plus 18 is -2, plus 27 is +25. Is that one greater than or equal to 0? Yes. Okay, so we do want to keep this last one. All right, so now we want to think about drawing our answer. So part 3 is giving our answer. So our number line, we've got -2 and 2. So let's start with our endpoints. If I go back up to my inequality, this is an or equal to. So both of those numbers are going to work, right? My endpoints count. So yes to this point, yes to this point. Then I don't want either of the first two ranges. I don't want things where 0 are, and I don't want things where -3 are. But I do want this last interval from 2 on to infinity. Okay. So that's what my graph would look like. And I mentioned with that -2 showing up twice, that kind of creates this extra point over here that works, but nothing around it works. And that's kind of a product of what's going on there. The way you would enter this into WebSign, if you're looking at interval notation, that -2 by itself, we write with braces around it. It's just a single point. Union, the interval, we're going to include our 2 and go off to infinity. So that's what my answer would look like. On to number 3. All right, we're going to start with number 3 in a slightly different way. Before I go and solve anything, I'm going to look at the numbers that we can't have. So the numbers that we can't have are when the denominators are equal to 0. So I'm going to look at this denominator and this denominator, and I'm going to set them both equal to 0. So I'm going to take x minus 2 equal to 0, and that's when x is equal to 2. That's a point that's just not going to work. I would get something undefined if I plug in 2. I'm also going to do the same thing with the second denominator. So x plus 1 equals 0 will give me x equals negative 1. So both of those are points that don't work. Then I'm going to follow the same procedure. So part 1, we're going to solve the equation. So 1 over x minus 2 is equal to 3 over x plus 1. Okay, now how do we solve this? Well, actually, I'm going to move this over a little bit. We're going to clear our denominators. So we're going to multiply by both denominators. So by x minus 2 and x plus 1 on both sides. Some of us are having trouble with what cancels and what doesn't because we're not writing it all down. So I'm going to show it to you in detail here. On the left-hand side, the x minus 2's cancel because I have 1 in the numerator and 1 in the denominator. On the right-hand side, the x plus 1's cancel. So what do I have left here? On the left side, I have x plus 1 times 1, so I don't have to write it. On the right, I have 3 times this x minus 2. Then I can go ahead and distribute and simplify. So this becomes 3x minus 6. And then I can go ahead and subtract an x. And I can add a 6. And that's going to give me 7 on the left and 2x on the right. Now if we divide by 2, that gives me x equals 7 halves, which is 3.5. So that is my third point. Okay, so I've got the 2 that don't work, and I've got this third point that I found. Okay, so when I set up my intervals, I'm actually going to put all 3 points on there. So I've got negative 1, 2, and 3.5. So negative 1, 2, 3.5. And then I'm going to choose a test point in each interval. So I'm going to go with negative 2. 0 is in there. 3 is in this interval, and 4 is in this interval. And we're going to plug it into the original. So we're going all the way up here. We're going to start with negative 2. So when x equals negative 2, I have 1 over negative 2 minus 2. Greater than or equal to 3 over negative 2 plus 1. What I get here is 1 over negative 4, or negative 1/4, is greater than maybe. Let's see. And so I'll put a question mark above that. We're not sure yet if it's greater than or equal to. And then we get 3 over negative 1, so negative 3. So is negative 1/4 greater than or equal to negative 3? If you don't like working with fractions, you can also multiply both sides by 4 here. And you get is negative 1 greater than or equal to negative 12? And that's true, right? Negative 12 is much more negative, much smaller than negative 1. So that's a yes. So I'm keeping, oh, wait, we forgot to write out our intervals down here. Let me do that quick. Negative infinity to negative 1, negative 1 to 2, 2 to 3.5, and 3.5 to infinity. And this was a yes on the first one. Now we're plugging in 0. So if x equals 0, we get 1 over 0 minus 2, greater than or equal to 3 over 0 plus 1. And that gives me negative 1/2, greater than or equal to 3. Is that true? Definitely not, right? A negative number is not bigger than a positive number. So we're going to cross this one out. Then we're going to test x equals 3. That gives us 1 over 3 minus 2 is maybe greater than 3 over 3 plus 1. That's 1 over 1, so just 1. And this becomes 3/4. So is 1 greater than 3/4? Yes. So we're going to keep that interval. And lastly, we're going to check x equals 4. 1 over 4 minus 2. Is it greater than 3 over 4 plus 1? This becomes 1/2 is maybe greater than 3/5. Now, if you're not sure again here, you can multiply by both denominators times 2 times 5. Over here, the 5's cancel, and over here, the 2's cancel. So that's going to give me 5 times 1. Is it greater than or equal to 3 times 2, which is 6? And that answer is no, so that one's not going to work for us. Okay, and then our last step is to go ahead and write out our solution. So I'm going to do my number line, and I've got -1, 2, and 3.5. Okay, let's start with our endpoints. When I go up here, there's these green numbers. Remember, those were 2 points that weren't going to work. So -2 and -1 and 2, I have to put open circles around because those points don't work. And then my inequality is the greater than or equal to. And so that means that I can get 3.5. Remember, I got 3.5 from setting it equal. So we include the 3.5. And then we look at our intervals and we say, the first interval is yes, so this one, yes. Second one is no. The third one is yes. And the fourth one is no. So I end up with 2 intervals here. We go from -infinity to -1, do not include. Union, 2 not include, to 3.5, do include. Okay, and that would be our final answer on that one. And then our final question down here, we've got number 4. So same idea that we did with number 3. So first thing we're going to do is say, what numbers can't we have? So I'm going to look at my 2 denominators and set each one equal to 0. So 3x minus 5 equals 0. Add the 5, divide by 3. That gives me 5/3, which is 1 2/3. And then you're taking x minus 1 equals 0. Add the 1 to both sides, and you get x equals 1. Okay, so these are numbers I can't have. So when I draw my number line, open circles around those, right? All right, then we're going to start our process. So we're going to go over here. Part 1, we take that inequality and we're going to solve its equation version. So same exact thing, only switch out my less than or equal to for just a regular old equal sign. Then we can go ahead and solve this, and we do that by multiplying by both denominators. So this we're going to multiply by x minus 1 and 3x minus 5 on both sides. Then we can cancel what they have, what cancels, so 1 on top, 1 on bottom. And then I can go ahead and distribute what's on top. So x times x minus 1 on the left, and 2 times 3x minus 5 on the right. If we go ahead and distribute, that's x squared minus x and 6x minus 10. Let's subtract these 2 over, so minus 6x minus 10. Make sure you are subtracting like terms. That gives you 6x squared minus 7x minus 10 equals 0. Let's see here. Can we get 2 factors of 10 to add to -7? So -2, -5, but that would give me positive 10 and -7. 10 and 1 would give me a 9. I don't think this is factorable. So, oh wait, hold on 1 second. I think I made a mistake, and that's why. Let's go back up here for a second. This is a -10. If I want to clear it, I've got to add 10 to both sides, and then we get a positive 10 down here. Then the -2, -5 is going to work, right? So x minus 2, x minus 5. If you didn't get that, go quadratic formula. It'll give you the exact same answer. Okay. That will give me x equals 2 as a solution, right? Set it equal to 0, move the 2 over. And this one's going to give me x equals 5, right? Essentially, we do whatever's opposite of that sign that's in your factor, okay? All right. So now, when I go to create my intervals, step 2, create my number line. Now, I have 4 numbers to put on here. I have 1, 2, 5/3, and 5. 1 is the smallest, so I'm going to put it down here. 5 is the largest. That one goes up here. And then, let's see, 5/3 is the same as 1 and 2/3, so that's smaller than 2. So I'm going to put 1 and 2/3 here and 2 over here. If you need a decimal equivalence, 1 and 2/3 is 1.67 approximately, okay? All right, so let's create our intervals. So we have -infinity to 1, 1 to 1 and 2/3, 1 and 2/3 to 2, and 2 to 5, and 5 to infinity. So many intervals to check. All right, so let's choose a number. 0 will work over here. I'm going to go 1.5 in the middle. I'm going to go 1.75 over here, 3 and 6. I've got to plug all 5 of those into the original inequality. So let's do that. So we're starting with 0. Okay, so for x equals 0, I have x over 0 minus 5. Wait, whoops. 0 over 0 minus 5 is less than or equal to, maybe, 2 over 0 minus 1. On the left, that's 0 over negative 5. And on the right, that's 2 over negative 1. So that's 0 less than or equal to negative 2. Is that true? Definitely not. Negative 2 is smaller. So that's a no. So we're going to cross out that first interval. Then we're going to check 1.5. So x equals 1.5. So 1.5 over 3 times 1.5 minus 5 is less than or equal maybe to 2 over 1.5 minus 1. This is 1.5 over. 3 times 1.5 is 4.5. Minus 5 is going to be negative 0.5. Is maybe less than 2 over 0.5. Use your calculator here. 1.5 over 0.5 is going to be negative 3. Maybe less than 2 over 0.5 is going to be 4. That's a yes. Negative 3 is less than or equal to 4. So we're keeping the second one. All right, next we're plugging in 1.75. The decimals are a little tricky, so be a little bit careful here. 1.75 over 3 times 1.75 minus 5. Is that less than or equal to 2 over 1.75 minus 1? All right, so this is going to give us 1.75 over 3 times 1.75 is 5.25 minus 5 is 0.25. Is that less than or equal to 2 over 0.25? All right, 1.75 divided by 0.25 gives me 7. Is that less than or equal to 2 divided by 0.25? Use your calculator here, you get 8. Is that true? Yes, that's true. So I'm going to go down here and say yes. It does work. Okay, next we check 3. Running out of space. Let's see if we can get it in here. All right, you're doing 3 over 3 times 3, which is 9 minus 5. Is that less than or equal to 2 over 3 minus 2, right? Oh, minus 1. Okay, that gives us 3 over 4. Is that less than or equal to 2 over 2, which is 1? Yes, that is true. So this one is also a yes. And then we want to look at 6. So for x equals 6, 6 over 3 times 6 is 18 minus 5. Is that less than or equal to 2 over 6 minus 1? So we have 6 over 13. Is that less than or equal to 2 over 5? All right, and let's see. We can both multiply both sides by 13 and by 5. That way, 13s will cancel, 5s will cancel, and I get 30 is less than or equal to 26. That's a big no. Okay, so that one's not going to work. We're going to cross that one off. Now that we've tested all of our intervals, we can go ahead and put together our answer. So I've got my big number line here, and I've got 1, 5/3, 2, and 5 on it. And let's check our endpoints first. So going up to my green numbers up here, I can't have 5/3 or 1. So I'm going to leave open circles at 5/3 and 1. Then the 2 and the 5 came from my inequality, and my inequality was or equal to. So those get closed circles. And then when I'm looking at this, the first interval is a no, but the next 3 are yeses. So this one, and this one. And that means we have from 1 to 5/3 do not include either. From 5/3 all the way to 5 because I include the 2. So I can actually color all that in and go all the way across. And then I close the bracket at 5.